Hello everyone, in this video lecture we will discuss about the main aim of the numerical analysis. Numerical analysis is basically used to compute approximate solution of those problems whose analytical or exact solution is not possible. Let us discuss about a real life problem, traffic flow problem. Problem we want to analyze this mathematically. So what we will do, we will make its model with the help of some laws, etc. And in that particular model we are getting highly nonlinear equations. Okay, those equations are not easy to solve. For that we will take the help of computer or some methods. Those may help us to get solution of the mathematical model. So whenever we are using computer in our system, or whenever we are getting some approximate solution, in that case we are getting error. So first of all we will discuss about error and how much error is responsible to get a wrong solution of our problem. Okay, so let us take an example of error. Suppose you want to compute under root 3, then the value of under root 3 is what? 1.732 and so on. It is going up to infinity. The value of under root 3 is going starting from the value of under root 3 is what? It is an infinite series, or we can say it is a irrational number, so it is going up to infinity. So suppose we are computing under root 3 square, so it is what? It is 3. In traditional mathematics we are saying under root 3 square is what? Under root 3 multiplied by under root 3, it is coming out to be 3. But in computational method it is not so. Suppose we are taking 4 digits of root 3, okay, 1.732, and we are finding its square, then it is coming out to be 2.999824. So this value is not exactly 3, but it is approximately equivalent to 3. So whenever we will use this under root 3 in our calculation, so we are not getting actual result. So we are getting some error because of this term, as exact value is this and approximate value is what? 2.99824. Okay, so similarly we can take one more example, x equal to 1 by 3. Here the value of 1 by 3 is what? That is going up to infinity. It is having infinitely many digits. Okay, if we want to compute the value of x square, then it is not possible to work with infinite digits, so we have to cut this series somewhere in between. Okay, so let us take only 4 digits. So floating of x, we are writing the approximate value of the x as 0.3333. Okay, so after truncating the series we are getting this number. This value is not actually equivalent to the exact value of 1 by 3. Okay, so whenever we are dealing with finite digit, in place of infinite digit, we are introducing error in our system or in our computation. So even a small error may propagate in subsequent steps, so that we may get very wrong result. Okay, so let us discuss how a computer recognizes a floating point number, or what is the representation of a number whenever we are dealing with computer or calculator. So let us discuss floating point representation of a number. So a real number can be written in the form of plus minus 0.a1, a2, a3, an, and so on into 10 raised to power e. The e is exponent and the term inside the bracket is called mantissa. Mantissa. Let us denote this mantissa by capital M. So the value of capital M is lying from 0.1 to 1. Okay. Floating of x. X is what? That is a number that is having infinite many digits. Floating of x is what? That is the approximate value of x. So let us take n values, n digits of x. So floating of x is what? Plus minus 0.a1, a2, a3, an into 10 raised to power e. Okay, where the value, where ai is what? If we are talking about I equal to 1 to 3 up to n, it is taking value from 0 to 9. You are free to choose any of the values. So ai is as from 0 to 9 and I equal to 1 to 3. We can simplify this floating point representation into another form that is called normal form. Normal form is what? Whenever we are restricting this a1 as not equal to 0, then this representation is called floating point representation. Normal form of the floating point representation. Okay. So a1 is not equal to 0, but a2 to an, they may take any value from 0 to 9. So if we are having this condition, then we'll say the number floating of x is in normal form, or a1 is not equal to 0. No, why? What is the reason why we are talking about normal form? Because normal form is what? That is an unique form, and it is different from floating point representation. As we can understand with the help of example, there are infinitely many representations of floating point numbers, but normal form is unique. Suppose x equal to 0.0056. This is what? This number can be written as 0.056 into 10 to the power minus 1. Also, we can write this number as 0.56 into 10 to the power minus 6, or 0.00056 into 10 to the power 10 to the power minus. Okay, so normal form is what? That is unique form. Suppose we are having a number x equal to 1.23, then this number can be expressed in term of 0.123 into 10 to the power 0.0123 into 10 to the power 2, 0.00123 into 10 to the power 3, like that. Okay, but these are all floating point representation. Floating point representation. But suppose representation. But if we want a unique form, for that we will restrict this number after decimal should not be 0. So that's why we are calling normal form is unique. Now x is what? 5431. This can be written as 0.5431 into 10 to the power 4. This is in normal form. Otherwise, there are infinitely many representation of the number 5431 in terms of floating point representation. Let us discuss about significant digit. So what is significant digit? The number of digits in mantissa are called significant digit in X. Okay. So if we want to write we want to count significant digit of a number. So first of all, we will write that number in terms of floating point, normal form, and then we'll count its digit. So suppose x equal to 0.0023. So what we will do? Convert this number into normal form. It is 0.23 into 10 to the power minus 2. So this is the normal form. Now count digit after decimal. So there are 2 digits, so it is significant digit. Similarly, let's do some question based on significant digit. How many significant digits are in the number 3.5460? So what we will do? We will convert this number in term of 0.35460 into 10 to the power 1. Okay, so 1, 2, 3, 4, 5. So there are 5 digits. Similarly, in this question, what we will do? We will write this number as 0.5321. 0.5321. So this is what? This is normal form, and then convert it into significant. So this number is having 4 significance. So in order to compute significant digit of a number, write that number into normal form and then count digit after decimal. Okay. Next is finite digit arithmetic. As we have already discussed, whenever computer or calculator we are using in our computation, then it is taking only finite digits in their system. Okay. as we have already discussed x equal to 1 by 3 and we want to use 1 by 3 in our computation, then we have to fix digit of 1 by 3 up to some fixed number. Okay. So whenever we are fixing our digit, so there are two procedures. We are cutting our series after n digit. So there are two procedures. One is rounding and another is chopping. So we can cut our series by two ways. One is rounding and another is chopping. If we are, so what is rounding and chopping? Suppose x is a number 0.a1, a2, a3 up to an, going up to infinity with n discovery. And suppose we want to cut this series after n digits. So since we want to cut this series, or we want to take only n digit in our computation. So what we will do, we will cut our series by using rounding or chopping. So let us discuss what is chopping. Chopping means we will cut series after n digit and will not take any effect of the other term on this number. Then it is called chop. So floating of x is what? Take first n digit in our calculation. What is rounding? In rounding, you have to just keep in mind what is the n plus 1 at term. Suppose we want to cut our series after n term. So we will check what is the a n plus 1 term. If a n plus 1 or the next term is greater than 5, then we will add 1 to the previous element, that is to an. If an plus 1 is less than 5, there will be no change. It is similar to the chopping case. Okay. So this is called rounding. So we can write this thing in this way also: 0.a1, a2, a3, an plus 0.0001. That means we are adding one number to an. Okay. One more case. If an plus 1 is equal to 5. So we have discussed the case when an plus 1 is greater than 1, greater than 5, or an plus 1 is less than 5. Now let us discuss the case when an plus 1 equal to 5. In that case, we will check what is the number an plus 2. If an plus 2 is not equal to 0, in that case, an will be what? An plus 1. Okay. Suppose, so just keep in mind, if an plus 1 is 5, there will be two cases. First case is when an plus 2 is not equal to 0. When an plus 2 is not equal to 0, in that case an will be an plus 1. So x equal to what? 12.51. Round it up to 2 digits. So what we will do, we will write x equal to 12.51, and what we have to do, we have to round it up to 2 digits. So just think these are the 2 digits. So what we will do, we will cut the series after 2 digits. So next number is what? This number is 5. So this is what? This is the third element. We will check fourth element, whether fourth element is 0 or not. Fourth element is not 0, it is 1. So that's why we will add one element to this 12. So we will add 1 to 12. So the floating of x is coming out to be 13. Okay. Second case is what? We'll check again the case when an plus 1 is 5. In that case, in case an plus 2 is coming out to be 0. If an plus 2 is coming out to be 0, then what we will do? We will add an to an. If an is odd, so again there exist two cases. If an plus 1 5 and an plus 2 is 0, in that case we will check what is an. If an is odd, if an is odd, this an is odd. In that case, we will add one to an. Okay. If it is even, there is no change. An will remain as it is. Okay. So let us take an example. X equal to 11.50. Round it up to 2 digits. Okay. So what we will do? Up to 2 digits. That is like the number is what? 11.50. So we have to round it up to 2 digits. So we will take third element. What is third element? This third element is 5 and fourth element is what? 0. Fourth element is 0. Now we will again check what is the second element. Second element is odd as per this case. Okay, so we will add 1 to this. So 1 is odd here. That's why the rounding number will be what? It will be 12. Okay, one more example we are checking. X equal to 124.50, 12.550. You round it up to 3 digits. So 3 digit is what? 1 to 12.4. Okay, so we have to cut the series after 3 digits. So the next number is what? 5. So we'll take what is the next number to 5. It is 0. So we'll check what is the number an. A3 is what? 4. It is even number, so there will be no change as per this number. So what would be the value of floating of x? That is 12.4. Understand? There's some more examples we are discussing here. X equal to 0.123750 an plus, and what we have to do? We have to cut the series after 4 digits. An plus 1 is 5. Next number is even 0. So that's why we will check this number. This is what? Odd number. So we'll add one number to 7. So we are getting this. Next is 0.123450. So next element is 0. We'll take this previous element 4. It is an even, so no change. So 0.1234. Okay. So we are finishing it here.